Chapter 8 Additional Notes Knowing Your Laboratory. So far we have covered quite a number of topics within this module, Engineering Research. You have been introduced with what is engineering research, the ethical conduct in engineering research, conducting literature review and technical reading, writing technical papers, publishing research work, presenting research work, as well as the things that you need to know for the research and postgraduate studies. We know that engineering research are normally triggered on basis of some problems or some questions that needs to be answered. The ultimate goal of conducting engineering research is to formulate knowledge in order to fill the knowledge gap within the field of studies. For that, investigation program will be carried out. It is very much dependent on the field of study as well as the problems and the questions of the research that needs to be answered. There is quite a variety of ways for you to carry out the investigations, which can generally be classified into 3: experimental studies, numerical or computer modeling, and analytical modeling, which involve derivations of the equations. Different researchers may use different approach to carry out their investigations in order to acquire answers for the research. One of the popular methods being used in engineering research, it will be through experimental studies. That means the researcher needs to produce the samples resembling the actual situations, conduct testing, acquire results, observe the parametric response as a mechanism to explain the actual situations. This will involve the laboratory works, where most of the students going to do that in the laboratory. Sometimes may involve the viewers, and all this testing will need to be carried out carefully in order to acquire reliable results, which is closely resembling the actual scenarios that they are studying. This brings us to these chapters about knowing your laboratories, as there are quite a number of disciplines in engineering research: civils, electrical, mechanicals, and etc. Even within the same discipline, there are also quite a number of fields of studies. Let's say under civil engineering, there are structural engineering, material engineering, highway engineering, traffic engineering, hydraulic, soil and geotechnical engineering, and etc. Different fields of study will involve different sets of equipments, which there are quite a variety of apparatus, samples, setup, and so on and so forth. It is nearly impossible to cover all those in a module. Our discussion here will just follow certain areas which I'm personally more familiar with. For those who are within the same field of mine, the technical insight might be helpful to you. As for those who are not in the same field of mine, the principle behind these chapters will also be helpful to you. You may adopt the principles, how we look into the experimental works, why certain things need to be practiced. Those are generic and is applicable to different fields of studies. Without further ado, let us proceed with the chapter. First, know your laboratory. It is particularly for those who are doing the experimental studies. You know that you're going to work within some laboratory. It may only be one laboratory, or your works might involve several laboratories in a series. This is very much dependent on your topic as well as the facility available within your institutions. For civil engineering, these are the common types of laboratory. as typically possessed by most of the university, which include concrete workshop, material testing lab, structural or heavy structure lab, soil and geotechnical lab, highway lab, fluid and hydraulic lab, computer or CAD/CAM labs. There could be more. Some more established university may have more refined separations of their labs. As for the other discipline of engineering, there will be another series of labs. What is important here is you need to know your laboratory as you're going to work in the laboratory. There will be a series of equipments which you're going to use, either operate by yourself or with the assistance of the technicians. There will be potential risks if you don't do the lab work properly, which can lead to the damage of the equipment, as well as concern with your personal health and safety. For you to work in the lab, it is not just submit applications, filling up some forms, signing some documents, and then you are ready to use the lab. You will need to know the entire heads and tails of the labs for your own safety, as well as for the sustainability of the operations in the labs. These are the typical things that you need to know about your labs. What is the standard operating procedures within the lab? What should be done and what shouldn't be done in the lab? What is the standard procedures to operate the equipments? The rules and regulations in the labs, the health, safety and environmental HSE requirements, the PPE, personal protective equipments. You need to know the technical personnel and their contacts. You're going to work closely with them as they are the person managing the lab and assisting you in your lab work. You should also know the emergency contact in case that anything happens. Quick response can be conducted. There are also evacuations route plan. In the case of hazard, you know where you should go. You should also know the facilities and equipment available within the lab. This is also very important. You need to make sure that all the equipments and facility that is required in order for you to complete your research must be available, so that there are no unnecessary interruptions while you are conducting your research work. You should also know the layout of the lab, where the equipments are placed, so that you know where to access, and you should put it back after using the equipments. There will be inventory management. You will need to work this closely with the lab technicians, and you should also know the operating and opening hours. Some university only allow the labs to be operated during the office hour. Some may be opening for 24 hours. You should know all this before you actually enter the lab, and then be committed to comply with all the rules and regulations and behave in your labs. These are serious things. You need to do your work seriously. As a part-time member working in the lab, you are also responsible to ensure the health and safety, as well as the well-being of all the lab equipment. Most of these informations are being disclosed to you during applications and submissions of the document for you to admit into the lab, and there are many being displayed throughout your lab so that all the lab users can refer. It is always a good practice to read through all the forms, guidelines, rules and regulations during submitting the forms of applications to admit into the lab, as well as to walk around the lab reading everything that is being displayed on the wall, on the equipment, on the notice board, on the doors. Make sure you read every single notice, as well as the poster that are being displayed in the lab. Don't just ignore that, because when any emergency happens, you might not have sufficient time to read those for immediate actions. These are some examples of the notice that being displayed in the lab. There will be evacuation diagram, which typically showing you the layout of that particular building. What is your current positions? In the case of emergency, where should you go? What is the evacuation route? Every lab will have this being properly planned, and you should know that. Some university may conduct the emergency drill, which require the user of the labs to practice those. This could be a good opportunity to you to be familiar with the routes. If not, you should at least know the routes. This is another example, providing you necessary informations in terms of type of risk and its respective rating, recommending the PPEs required, giving you emergency contact, as well as other important contacts, and also some emergency guideline. Don't just ignore that. Carefully read through every single one of them. Those are not for the display only, and it is not for the lab technicians only. It is for everyone who are using the lab. Different lab may have different specifications in terms of the risk type as well as the rating. The PPE required or recommended may also vary slightly among different labs, depending on the type of experiment being carried out within the lab.